good afternoon, everybody. My name's Alison Henry, and I'm Head of Building Conservation at Historic England. And it's a great pleasure to welcome you to this final session of the Conservation Conference. And this session, we're focusing on stone slate and metamorphic slate roofing, probably the most widespread and distinctive roofing materials in the UK. We've got three excellent speakers for you this afternoon who between them have got an absolute wealth of knowledge on this topic. Well, I say we've got three. One is currently somewhere, I believe, in a taxi between St Pancras Station and here, but hopefully he's the last one, so hopefully he will turn up on time. But Ian is here, so we're going to start, if I could just introduce Ian Ramsay. So Ian has worked for 32 years with Burlington Slate, and Burlington Slate supplies the traditional green and blue and grey Cumbrian roofing slates that have been used on buildings for nearly 500 years at least. And Ian loves clambering over historic roofs because he knows that to understand how these roofing materials perform, you have to look back at the historic roofs. And with that understanding, that helps him get the best out of the new product. And in your role as sort of sales manager, he's forming that vital link between the supplier and the client, understanding what they want and then how Burlington Slate can deliver that and deliver a roof that will perform for another couple of 100 years. So I'm going to hand over to Ian. Thank you.
Okay, thank you, Alison, for those kind words of introduction. I do less clambering now than I used to do in my youth, but anyways, a good clamber over a roof is still a worthwhile process. So I would like to talk today about a couple of things, if I may. The traditional production techniques of Cumbrian slate, what that means for the format of the material, and what that impact that has on the buildings that the material's used on. But I would also like to give you a quick update on the production and availability of these materials. So just a quick word about Burlington, if I may. We are a 180-year-old family-run British business formed in 1843 by a gentleman called William Cavendish, who was the second Earl of Burlington, hence the name. And we are today still very much a family-run business, with Lucy Cavendish, William's great-great-great-granddaughter, being the sixth generation of the family to run the business. And we are, along with Honister Slate Mine, also a family-run business, the last guardians of a 450-year-old slate quarrying industry in Cumbria. Now, when we talk about Cumbrian slate, we're talking about two distinctly different geological materials. There is a green slate called Westmoreland Green, which is a sedimentary metamorphic volcanic ash, which comes from the Borrowdale volcanic group of mountains. That's those big rugged mountains at the heart of the Lake District, like these chaps here. And we have a blue-grey slate, which is a sedimentary metamorphic mud called Burlington Blue-Grey. And it comes from the gentler, more rounded rolling fells to the south of Cumbria, the Windermere supergroup. Now, the picture on the left, I hope, explains why the traditional production techniques of Cumbrian slate are what they are. Because of the very high incidence of geological faults in the quarries, block is one in all sorts of weird and wonderful and very unfriendly shapes and sizes. So you can see here a typical collection of block, or what the quarry call clog, sitting on the quarry floor, some very big lumps at the front, but right through to very small, scratty, unfriendly shaped lumps at the back. And it was the quarry's response to this random and unfriendly shapes of raw material to make slate in random sizes. So where block was big and fault-free, big slate would be made because it was more efficient to do that. There was less riving and dressing per ton. But where block was faulty or smaller, then medium-sized and small slates would be made. These random slates are sent to site. The slater sizes them into common lengths and lays them from big to small, eaves to ridge, which gives a very pleasing visual perspective to the roof. Now, the quarries made slates in completely random sizes. So they weren't sized to the nearest 2 inches or the nearest 1 inch. They were completely random in length and width. So you were as likely to get a 15 7/8 inch long slate as you were as a 16 1/4 inch long slate. And the slater would size those slates to the nearest half inch. And because of the double lap nature of natural slating, every half inch change in slate length manifests itself in a 1/4 inch change in course height. So it's a very gradual diminishment. And the quarries could only produce a small number of big slates and a bigger number of medium-sized and small slates. And it's this distribution of the sizes, along with the gradual diminishment, that seems to make intuitive aesthetic sense on the roof, with the bottom courses anchored by the very biggest slates, and then a bit of a drop to the next sizes, and then a gradual diminishment towards the ridge. Now this process wasn't some philanthropic act of goodness by the Cumbrian Slate quarriers who thought, oh, don't diminishing courses look great, let's make random slates. It was brute commercial survival. So if they didn't make use of every last scrap of raw material, they'd have been out of business. So it was classic production orientation. The quarry produced what it could, the building got what it got. And as a result, no two random Cumbrian slate roofs are the same. And this is very much the ethos and the spirit of random slating. And if you think about it, it's actually quite an early form of environmental efficiency, making best use of every last scrap of material that's been produced and minimizing waste. And historically, the architect had an important part to play in this process because they understood the geology of the material, respected that geology, and let it manifest itself on the roof without trying to control or manipulate the sizes. So how then, when you've absolutely no idea what size of slates the quarry is going to produce, do you go about specifying and replacing a traditional Cumbrian slate roof? Now I have to apologise here, Alison, for showing a Scottish project at a Historic England conference, but I think this best sums up the best way that we think to go about this. So this is Westerkirk Library in Langham in the Scottish Borders. It's an 1860s B-listed building, and it's slated with Burlington blue-grey, Cumbrian blue-grey slate, diminishing course slate roofs. Now, it was reslated 6 years ago, and we were able to, before the specification was written, visit the site on behalf of the architect, survey the roofs, and there's 7 different roof slopes in this building, but we were able to determine that between those 7 different roof slopes, the biggest slate at the bottom and all the different roofs was 32 inches. It was very clear that the top slates were about 10 inches. So the specification was written and the slates were supplied as 32 inches down to 10 inches in length. And they were supplied completely randomly between those 2 points, both in length and in width. And the result is that the newly slated building, across the 7 different roof slopes, slope for slope, each roof has a different coursing arrangement and a different number of courses to the original building. And this is very much in keeping with the spirit and the ethos of random slating. The alternative is to specify the coursing to exactly match the existing. And that presents 3 distinct challenges for the building and those involved. First of all, it's not possible to determine the coursing until the scaffolding is up. And that has an impact on the time for the project because you can't start to make the slates until the scaffolding is up. Secondly, it's a devil's own job for the slater to determine that coursing. It's a difficult enough job on a straightforward gable-to-gable roof when you've got 1 roof slope, but you add in multiple roofs and the complexity of hips and valleys and abutments, and it's a nightmare of a process to try and establish the coursing. And thirdly, of course, you're asking the quarry to force block that wants to make different sizes to make less efficient sizes. And all these things have an impact on time, and on cost. So they're not in the spirit and the ethos of random slating, and they're detrimental from a time and cost perspective to the project. So historically, almost all of the slate that was produced by the Burlington Blue-Grey Slate Quarry was random. Today, 50% of what we produce is random. It's still very much in our DNA to produce random slates, and 50% of what we quarry demands that it's produced in random sizes. The other 50% today, because of modern cutting techniques, allows us to make slates that are fixed in length by fixed widths, so set sizes, and fixed in length by random widths. But historically, most slates were random, diminishing courses, and it was very unusual to come across a set size Burlington Blue-Grey Slate. Now, this is two examples of current projects that we're working on to supply material. These are both Waterhouse projects, both built in the 1870s. He was working on both these two buildings at the same time, and they are both now Grade 1 listed buildings. So on the left, you see the Natural History Museum with the west wing slates being reslated, and they are the very usual diminishing course slates. So those are 32 inches down to 10 inches in length. Unusually, the building on the right are set size slates. That's Manchester Town Hall, where we're currently supplying some 350 tons of slate to replace the entire roof. And Waterhouse had used set size slates in that building because he'd introduced some banding courses with Westmoreland green slates in the shape of a W, which Purcell think was a nod to his own vanity. And in order to make that visually coherent, so the banding courses looked right, the slates had to be set sizes. Now, I promised an update on the availability of Burlington Slate. This is Kirby Quarry, which is the home of Burlington Blue-Grey Slate. And as you can see, following 450 years of quarrying activity, we have an increasingly deep and increasingly narrow quarry floor, because as you go down, you have to bench in, otherwise the walls fall in. And if we did nothing more, there's enough width in that floor to go down another 2 benches, which would give us another 10 years of supply. So clearly the quarry had to be widened. The drawing on the right shows that development plan. The pink shaded area is the amount of overburden that needs to be moved, which is some 4 million tons. But by moving that quantity of material, we expose 876,000 tons of good clog, of workable clog that will rive and dress to make roofing slates. So this is quite a considerable commitment by the Cavendish family. Some £5.4 million has been spent on this development, and demonstrates their commitment to the ongoing availability of the material for projects where important historic and conservation projects where this material needs to be supplied for the maintenance and replacement of Burlington Slate roofs. So we're well underway with that process now. The main muck shift is complete. While we were at the outset of the project, to an extent, while we were developing, we weren't able to keep up with day-to-day production of clog for roofing slate production, so our lead times got uncomfortably long. So about 2 years, 18 months ago, we were reporting 12-month lead times, which was very unhelpful. We're now again working multiple benches on the quarry floor, and lead times, I am pleased to say, have returned to a much more normal and manageable 2 to 3 months, 3 to 4 months sort of time scale. Turning then to the other material that comes from Cumbria, Westmoreland green slate. Just like Burlington Blue-Grey Slate, block was run in random sizes, slate was produced in random sizes. Unlike Burlington Blue-Grey Slate, Westmoreland green slate is a sedimentary metamorphic volcanic ash, and that volcanic ash nature of the material makes producing big slates more difficult. So as a generalization, compared to Burlington Blue-Grey slates, the biggest slates are smaller, and the proportion of big slates as a percentage of the whole is less. So what do I mean by that? Well, this is a typical Westmoreland green slate roof on a series of cottages in the Langdale Valley. There is one big bottom course, which is I reckon about 24 inches long, so a bit smaller than the blue-grey slate bottom courses we were looking at. And then very quickly that drops down to probably 20 inches and diminishes up to 9 inches at the ridge. And this, I think, highlights something that's really important. If you're a conservation professional working on a Westmoreland green slate roof, it's very helpful to have early contact with the quarry so that there can be some understanding of what that coursing arrangement is. So, for instance, if you're working on a replacement of a nave roof, which is 400 square metres, which might be 20 tonnes of slate, and the quarry gets an inquiry for 24 down to 9-inch long slates, what it doesn't think to itself is, well, we better give equal tonnage of each individual length, 24, 23 and a half, 23 and so on. But what it does think is it would be fair and reasonable to give roughly equal tonnages of the 4 intermediate size ranges that it would split that overall length range into. So 5 tonnes each of 24 to 20s, 20 down to 16s, 16 to 12s and 12 down to 9s. The quarry then says to itself, well, hang on a minute, we haven't got enough block to make 5 tonnes of 24 down to 20s. We better tell the project team we can only do 20 down to 9s. But if, under the guidance of the conservation and professionals who are involved in the job, there's an appreciation and understanding that actually maybe you only need 5 or 10%, so 1 or 2 tonnes of the big slates, then those can be produced and a much more authentic and appropriate size range of materials can be produced. It would still be different, the coursing would be different, but it would be more in keeping with the original coursing. So early engagement with the quarry is really important. To give you an update on Westmoreland green slate production, these are the 3 remaining Westmoreland green slate quarries that are working. There was some 60 quarries at one stage working in Cumbria. There are 3 left. So Honister in the Borrowdale Valley down in the bottom left, Broughton Moor Quarry, top right picture, just the south and west of Coniston, and Elterwater Quarry in the Langdale Valley at the bottom right there. Unlike Burlington Blue-Grey, Westmoreland green slate quarries differentiate between clog that will rive or split for roofing slate, which they call metal, and clog that won't rive, which they call monumental or architectural block. Now, between these 3 quarries, levels of production of metal, of riveable clog, is actually really good, and therefore production levels are really good. But we are experiencing very high demand for Westmoreland green slate, so lead times have crept up. We're in the region of 6 to 7, 7 to 8, sometimes 9 months plus. So in order to support that, we are making Westmoreland green calibrated slates. So as I said, not all block is metal, it won't all rive, but it will all saw. And when you saw block, you're very much sawing with the nature of the material, with its cleavage. So you're sawing with it in the direction that gives it inherently that very high flexural strength and very low porosity, which makes it ideal for use as a roof covering. So it's quite possible to saw blocks into slabs that are the thickness of a Westmoreland green roofing slate, some 9.5 mil thick, chop those slabs up into genuinely random sizes, texture the face of them so that they have a riven appearance, and then dress the edges. And these are the 4 roofing slate, Westmoreland green roofing slates that are in production at the moment. So left to right, we have Elterwater riven, Broughton Moor calibrated, Broughton Moor riven, and Honister riven. And this is an example of some of the recent body of work that we've done with calibrated, Westmoreland green calibrated slates. So clockwise, top left, going round, you have 22 Grosvenor Square in Mayfair, Morley House in Regent Street, Camden Town Hall, and Carlisle Memorial Church in Belfast. And with the exception of the church, the other 3 buildings are Grade 2 listed. And what's been really important is that the quarry's been able to supply like-for-like replacement of Westmoreland green slates in a timeous manner so that these projects can fulfill their project programs without delay. Now, one of the other great advantages of calibrated slates is that you can make them in any size. So this is St James's Church in Castleacre in Norfolk. It's a Grade 1 listed church. And the scope of the works here was the reslating of both sides of the chancel roof. The plan was to strip the existing slates, make as much use of the existing as possible, and supplement with new slates to match. You're always a hostage to fortune on the big bottom courses because there's nothing bigger than that to dress down to make up for any breakage. So the plan was always to replace the bottom two courses, which were 38 inches long, with new slates, and then the next 6 or 7 courses, which were 32s down to 24s, to make a small proportion of new slates to supplement the breakage and damage of the existing slates, and then the remainder of the existing slates could be made to use to finish the top half of the roof. So knowing that these were very big slates and we would require a very big block, the architect was able to give us 12 months to produce the block. At the end of that 12-month period, we had block big enough to do the 32s down to 24s, but not the 38s. So they were made in calibrated slates. So this roof demonstrates the 3 different materials working in harmony together: Westmoreland green calibrated slates in the bottom course, and a combination of riven existing and new slates in the remainder of the roof, allowing the original coursing to be, if not completely replicated, at least respected. So one last slide before I hand back to Alison. Really just to say we would encourage early engagement with the quarry. So whether it's to understand the provenance of the material, because these two materials do weather very closely towards each other in appearance, and it can be a bugger to tell the difference between them actually sometimes. Whether it's to understand the coursing and the sizing and therefore the slating strategy, or to understand the project program, all of these things, all of these reasons are good ideas to discuss with the quarry at early stages. And that's myself and my 2 other colleagues who are responsible for connecting the important historic and conservation buildings that you work on with the quarry. We are the link between those 2 things. And just to finish, to say that Historic England are talking about the introduction of slating champions. So in each of their different regions, on projects where they are funding, somebody in each of those regions will have the remit of connecting the building with the quarry to make sure there's early engagement and these sort of discussions can take place. So with that, I will just leave you with a few examples of some of the most iconic projects that we've been privileged to supply material to, and hand back to Alison for some Q&A.
Questions, I hope, yeah. Well, thank you very much. That was, do we give you a round of applause now? Yes. Thank you. Yeah, and I'm so envious of you working in the Lake District. It's the most beautiful part of the country.
Yeah.
Right, have we got the mic? Yeah, we've got the microphone there. So are there any questions then for Ian? Yeah, we got one there.
Thanks very much. It was just which of the quarries supplying the Westmoreland do you actually control, or are any of them yours?
Yeah. Broughton Moor and Elterwater are Burlington owned and operated quarries. Honister is owned by the Wilkinson Weir family, and they quarry and supply material through Burlington.
Do you happen to know the underlying minerals that colour the slates, the green, the blue-grey? Thanks.
Yeah, the mineralogy of Westmoreland green slate is chlorite that gives it its green colour. And as I say, it's a sedimentary metamorphic volcanic ash, so you very often see in the face of Westmoreland green slates that linear volcanic ash bedding. Burlington blue-grey is a sedimentary mud. I can't tell you offhand the mineralogy of that which gives it its blue-grey colour.
Are they fixed traditionally with copper nails all the time?
Yes, the current British standard would guide you to the use of copper nails. A lot of slaters still like to use galvanised nails because they're a bit more solid, but there's a theoretical weakness that the galvanising can rub off as it rubs against the slate and the head of the nail falls off. If you go back far enough, of course, they were fixed with sheep bones and oak pegs and hung on very thin timber lats.
Would that be torched with lime mortar on the underside?
Sometimes, yes,
Yeah.
historically, yeah.
Yeah. Another question here.
Now, do the slates actually come shouldered at the quarry?
Very often, yes. Shouldering as a process aids fixing because the head of the slate sits on the batten above, and therefore the less width there is in contact with that batten, the flatter the slate can lie. So historically, you would find a bank of men with a whittle and a brake dressing slates by hand. Now that's a very invasive and damaging process now. So there are mechanical means of dressing slates, but we use rotary dressers, and as they're being dressed, as the chap's offering the head of the slate to the rotary blade, he does take the corners off. So yes, going back far enough that they were very commonly dressed round. The heads of the slates were dressed round, which was a sort of process of them showing off their skill at dressing and the quality of the slate that would let itself be dressed round. And it earned the name of the men who worked at Kirby Quarry, the Kirby Roundheads. And that was a process that was stopped kind of mid to late 1800s because the managers at the quarry realised that not only was that a time-consuming process that took longer to do, it was actually losing the very thing that the material was sold by, which was weight. So it was taking longer to do it, and you were getting less money for it. So they were then dressed square-shouldered. Yeah.
Thank you.
We got any more questions? I just wanted to pick up on one thing because you showed that it was almost the penultimate image, which showed the gauge slates on that roof, and they were sort of blended in.
Yeah.
Now, I just wondered what's your sort of feelings on, if there is a project and there are some slates that can be salvaged, but you haven't got enough, and you have to buy in some new. Do you tend to sort of recommend that they blend on the same roof slope, or would you tend to advise to put all the new on one side and all the old on another?
Yeah. There's probably two answers to this question. I can give the only answer I would understand, which is the slate quarrier's answer.
Right.
But I accept there are conservation principles that sometimes would hold sway over that. But from the slate's perspective, if you're mixing new and old slates, you're condemning the new slates to be stripped and reslated at the same time as the original slates come to the end of their life. So empirical evidence tells us that Burlington blue-grey slates will last 150 to 200 years, and Westmoreland green slates probably another 100 years beyond that. So if you're stripping a roof with the slates that are 100 years plus 150 years, then in blue-grey terms, you've maybe got 50 years life left in those reclaimed slates before the new slates then have to be replaced. So from a quarrier's perspective, the logical thing to do is to keep them on separate roof slopes.
Yeah.
Much of that depends on how much flexibility you've got on a project. If you're doing one roof slope, or it's two sides, the classic two sides of the nave are both 400 square meters, and you manage to salvage 390 square meters, you haven't got enough to do one side. But yes, better to keep apart if you can from the slate's perspective.
That makes a lot of sense. Yeah. Right, I think there's time perhaps for one more question, if there's any other questions. No, okay, right. Well, thanks again, Ian. That was really brilliant.
You're very welcome.
So I'm going to invite John Owens to come up. So we're moving now from one fantastically beautiful part of the UK to another. So this time to Snowdonia in North Wales. And John Owens is the technical manager for Welsh Slate. And John, you've worked in a whole range of the sort of quarrying or aspects of the quarrying industry, including extraction and research, and now really focusing on technical advice. And again, that link with clients and giving them the best technical knowledge to help them get the most out of Welsh Slate. So we just got that up and running.
Yep, we're up and running.
Brilliant. Okay, over to you, John.
Marvelous.
Thank you.
Thank you, Alison. Thank you, everyone, for coming along. We're going to speak about there may be a bit of overlap because slate quarries are slate quarries. So you've heard a bit about Burlington. Welsh Slate is geologically slightly different, but there are some similarities. We're going to focus a little bit on the sort of sustainability of Welsh Slate, a little bit of history and the company and whatever else. So Welsh Slate is part of the Breedon Group of companies. They acquired us almost by accident in 2018. I don't think they knew that we were part of an Irish group that they bought. So it's been a bit of a learning curve for them in terms of slate and what it is, what it does. The Breedon Group are basically an aggregate, cement, asphalt, and concrete product company. Their sort of expertise in that side of things has brought something to Welsh Slate, which we'll sort of touch on later on. A little bit of history of Welsh Slate. The earliest recorded use of Welsh Slate dates back to the Iron Age, where slate was used in sort of chambers, burial chambers, and memorials and this kind of thing. The earliest use of Welsh slates as we know it in relatively small individual pieces dates back to the Roman occupation in the 3rd century. So you've got places like the Saguntium fort in Carnarvon and various other sites that used Welsh slates locally available and workable. The next big step was dear old Edward's conquest of Wales. It did take him 2 attempts, which consoles us Welsh people. And he used Welsh slates on the castles that he used to secure the boundaries of his control. Within the 14th century, Welsh slate started to develop shipping around the coast of Britain, short-haul shipping also across to Ireland, to Northern Europe. Big changes happened really in the 18th century. Timber became scarce. Prior to that, a lot of local indigenous stones would have been used to support the local building. That used an awful lot of timber. Welsh slate and slate in general was lighter, so therefore if there's a shortage of timber, that became more popular. The Industrial Revolution changed the fate of Welsh slate completely. Industrialization, mechanization allowed more blocks to be moved, heavier pieces, transport networks increased, and combined with that, there became an increased urban population. So we had an increased ability to produce, and there was an increased market of people wanting housing in the new mill towns and whatever came with that. Unfortunately, the 20th century for us has been a tale of constant decline, alternative materials, quarrying difficulties as a quarry gets older, as Ian sort of touched on. All the clever people before us took all the nice easy pieces, and it becomes gradually more and more difficult. So Welsh Slate operates 3 quarries. The first of these is Cwtabigal. This is in the Ffestiniog region, produces a blue-grey slate. Cwtabigal is most notable for its the highest industrial activity in the UK, at over 500 meters, and it's so remote that they decided to use it to hide lots of national treasures during the Second World War in the various chambers there that were altered, and air conditioning and whatever else added to climate control. The other quarry in that region is the Ffestiniog quarry, again a blue-grey slate, Ordovician in nature, so a metamorphic stone. Slight difference in characteristics, but basically the same geology to it. And thirdly, there's the Penrhyn quarry, the biggest slate quarry in the world in its time. Produces a heather blue and small amounts of quite a plummy red kind of slate. Penrhyn quarry has always been an open pit because of the nature of the quarry. both Festiniog and Cwtabigal were originally mines that are now being open casted because the material was laid down almost horizontally, whereas Penrhyn is vertical. So we just touched on it. Slate is a metamorphic rock formed from sediments laid down underwater, compressed by tectonic movements, huge pressure, basically made the minerals realign. So when a slate is split or cleaved, whichever terminology you want to use to it, we're not actually splitting in the plane that the material was laid down in. It's a cleaved plane. It's a completely new plane that's formed by that pressure. So that's what allows slate to be split far more thinly than a stone. So you can, because it's got a flexural strength, because it's a new plane. There's a short video of John Joe Bach here. Sorry, that's little John Joe to everyone. Splitting a slate. If I can get the video to work, there we go. So you can see he's actually marking along the edge the line that he wants to split to. So that's the edge of the slate rather than the head. So he's marking to weaken that plane. Then he works from the head, only using the chisel, you'll notice, to open the actual cleave of the rock up. That chisel's not been driven through. It's opening the cleave, and then its gentle leverage back and forth is allowing that cleave plane to come apart. John Joe is showboating a little bit at this time because normally he'd be a bit quicker than that. But you've got control with having that manual dexterity to it. You control how that split goes. So as I say, those slates were 32 inches long. So I said we'd talk about sustainability. It's quite a peculiar thing to talk about when you're digging a resource out of a mountain and whatever else. But everything is finite in the end, unless it's grown. So it's how we're being more sustainable. So we move about 1 million tons of material annually, and of that, only about 1 to 5% makes roofing slate. We're probably at the moment closer to the 2% in reality. That makes sustainability even weirder. It focuses in importance, therefore, on use of other materials, or that material for other uses, sorry, I should say. So Ian touched on earlier how you can have an awful lot of slate that has solid, compact, but will not cleave. And we use that basically for dimensional stone, which can be used as cladding, countertops, and this kind of thing. There's a hierarchy to the way. So roofing is the first product, then the dimensional stone, then a paving, which you would make out of material that would cleave, but would only cleave to probably about 1 inch thick. Not suitable for roofing slate. We can make paving units out of it. Walling, small jointed blocks that wouldn't make roofing slate are then made into walling, whether that's a 100mm bed or a completely random. Various applications for that, but because of the nature of slate, it's got a density, water absorption equal to a Class B engineering brick, so you can use that as a facing or a fully supporting. The next stage is, if it won't do any of those products, we'll try and convert it into some kind of a crushed. We produce minerals and powders. Anyone who's got a shed at home that's got some felt on it, likelihood is it's probably got some mineral on it that's come from a slate quarry, and high likelihood it probably came from one of ours. And seems quite an anathema really to have a resin bonded slate there, but that's where we supply a lot of the powders to, is products like that. And the sort of lowest form and the catch-all is then an aggregate, which is partially where we fit in with the Breedon Group. They've got strong connections within aggregate customer bases and uses. So any waste that comes from any of those other income streams gets crushed. You've probably seen purple slate in garden centres and whatever else. That will have originated from Penrhyn Quarry at some stage or other. Breedon have invested quite heavily in that side because that's where their natural interest lies. So they've invested in developing a railhead. The problem with aggregates is invariably once you're about 50 miles beyond the quarry, the haulage is a higher content than the value of the slate inside it. So hence they put a railhead in. You can put 7,000 tons on a rail line and suddenly get that moved around the country far more efficiently and effectively. We're going to touch on the sort of production, the techniques, how that's changed, what implications there are for that. There's a couple of contrasting images there. The original method of quarrying would have been to open the blocks, exploit natural jointing, would have been a system of wedges, levers, bars, just prizing pieces of rock out. You'd have men working on ropes dangling from faces. I don't think our health and safety regime would like that these days. In fact, to the extent that Welsh Slate quarries had their own hospitals on site, which specialised in amputations of crush injuries. More modern techniques of extraction would be drilling and blasting, where you would stitch drill. So you'd drill a series of holes, probably about 700 mil apart, horizontally and vertically. Those would be charged with black powder. It's a low explosive. So just basically the theory being to join those holes together, lift and push the block out. The most sustainable means of yielding that block is, as you can see in the image on the right there, is diamond wire sawing. So even though black powder, gunpowder is low explosive, creates as little damage as possible, it does still create damage. So if you can wire saw that block out, again, you're just enhancing your recovery. Blocks would have traditionally been reduced, again, chisels, block and feather, gudgeons, various tools that the men would have used. That's been replaced by diamond sawing, 900 mil diameter diamond saws, slice those blocks up to handleable sizes. Slate splitting. The slate splitter you see in the old image would probably find a lot familiar in the modern image. There's not a great deal has changed in that. How his materials delivered to him has changed, but the actual process is basically identical. We manually split about 65% of our slate. So as you see there, we have got automated splitting, whereby there's a machine basically tries to replicate what the man does. As we saw with John Joe earlier, prizing the block apart, unfortunately a machine can't prize and control. So the automated splitting relies on compressed air, so that the chisel will open the cleave up, and then there's compressed air fired into that joint that cleaves the blocks apart. The men are far more successful in terms of recovery. The machine is quicker. Dressing to size, you can see the traditional method, a knife and a bar. You would just, as Ian touched on earlier, you would just keep nibbling the size away until you got a rectangular piece of slate. That later changed to guillotines, rotary guillotines. Unlike Burlington and Westmoreland, the Welsh Slate quarries very, very quickly got onto producing fixed size slates. They had generally more uniform sizes of blocks and this type of thing. So the Welsh Slate quarries, from probably the early 1800s onwards, were generally producing fixed size slates. So that sort of suited the image you see on the other side is automated dressing. So again, to enhance our yield, to improve the sustainability of that material, rather than an impact dressing the edge of the slate to final size, that's now nibbled away with a cutting blade. And we've got all our dressing to sizes automated. The one that you see in the image there is a completely automated system where a sawn edge riving goes in at one end. and comes out the other end graded, holed for a final quality check from our experienced workforce, and then packed. Because the automation of dressing, it's caused Welsh Slate to rationalise the sizes. So we now produce sort of 4 standard sizes. Historically, that would have been over 36 different sizes. But we can produce special sizes. Although we've got standardized production, we can produce special sizes, diminishing courses, shapes, coloured bands. Large size slates, that's Lincoln's Inn in London, that's 800mm long random widths. King's College in Cambridge, that's 1100mm down random width slates. So in terms of sustainability and conservation, in most circumstances, the size of a slate that ended up on a roof would have been a coincidence of the distribution network. So slates would have distributed by rail, by sea. Basically, the slates that went on the roof was what was available at your local dock or rail yard, invariably. There were regional variations where there were the specific reasons and this kind of thing. So the overall appearance of a slate roof can be defined basically by whether it's fixed size, random widths, the colour, whether it's large, medium or small, thick, medium or thin in thickness. Generally, those will override the general appearance. An example how a sort of slight a change in size of slate can have a minimal impact on a visual. If you had a 4 metre rafter length and you put a 600 by 300 slate on it, it would be 16 courses. If that was changed to a standard production size of a 500/300, that would be 19 courses. I think you'd probably have a very keen eye or a good seagull to tell the difference. So long as that colour, texture is there, then the overall appearance is going to be the same. Specifically to sustainability, the energy to produce a Welsh slate is extremely low. You can see it's about 1% of that of a clay tile. Based on an average UK 2-storey house of about 150 square metres, the energy used to make the Welsh slate roof for that would be less than 1% of the energy consumed by that house annually. That also equates to 1 Welsh slate would be the equivalent to boiling a kettle. Invariably, quarrying has an environmental impact. So you've got a visual. We dig great big holes in the ground. These are landscaped when we're finished with them, with local plants sourced and replanting of the tips. There's also a physical impact. We create a great big ditch in the middle of the ground. To the right of the quarry there's a registered wetland. The mountain is on the left. So basically we've dug a drainage ditch all the way around the quarry to ensure that sort of water coming down the hillside still irrigates the wetland. And of course you can reuse redundant areas of quarries. I'm sure you've all seen these zip lines and trampolines in old slate caverns, and I believe there's crazy golf there as well now. The thing that makes Welsh slate sustainable above all else is its durability. We mentioned earlier slates from the Roman era. That's a slate that was recovered from a bathhouse in Tremadog in an archaeological dig. There were several hundred of those slates recovered from there, and that's in our offices and is perfectly good to go on a roof today. So that's a testament to. There's another project, St Asaph Cathedral, that was re-roofed after 300 years, and they reused about 30% of the slates on there. So, in summary, Welsh Slate, we produce about 90,000 roofing slates a week across the 3 quarries. That equates to about 3,500 square metres. That on average is about 40 domestic houses. If conservators, clients can have flexibility in the sizes and what's appropriate, that can maintain the aesthetic, maximise economy and maximise the sustainability. Where there's something out of the ordinary, early engagements, again, as Ian was talking, with the quarry basically makes the project go easier. We are able to produce special sizes and whatever that you've seen, but it needs a bit of planning. And standard sizes maximise recovery, which maximise sustainability. And Welsh Slate, less than boiling a litre of water. So next time you boil a kettle, you could have made a Welsh Slate. And that's it. Thank you.
Thank you so much, John. That's absolutely fascinating. So I'm sure there'll be questions. Brilliant. One in the front row.
Are iron pyrites, I beg your pardon, are iron pyrites just a problem for Spanish and Chinese slates?
No, there's iron pyrite in all Ordovician slates. So in Festiniog and Cwtabigal, there are iron pyrites. It's how reactive iron pyrite is the defining point. Reactive iron pyrites will rust and corrode and leave holes and expand and break and everything else. Non-reactive pyrites are inert and basically just sort of are stable, so they don't rust in essence. They don't oxidize.
So are you assured if you buy a Welsh slate that that they would have been sorted out? They wouldn't be
Yes.
part of a delivery?
Yeah. In the Penryn quarry, there's no iron pyrite present. It just wasn't. It wasn't a mineral that was around when that slate was laid down. In the Ordovician, in Festiniog and Cwtabigal, there is.
Just to carry on from what our colleague was saying there, I've noticed the Delabole slate has got the rust characteristics of
Right.
they come from Cornwall, by the way. You can see them even when we replace them slates. You can see the rust stains coming down the actual slate. And also just something else about I think there's a Penryn Castle or Penryn House.
There is a Penryn Castle.
I remember visiting there some years ago, and from memory now, everything was made of slate. The coping stones on the garden walls were slate.
Yeah.
I think the floors were slate.
There's even a bed there that's made of slate.
Well,
Specially made for Queen Victoria, apparently, and she said it was distinctly uncomfortable.
well, it's quite funny, really, because even the skirtings were slate, and also the kitchen sink was slate.
I wonder if Lord Penryn paid for it.
Hey?
I wonder if Lord Penryn paid.
Yeah, just amusing, really. Yeah. Thank you very much.
Thank you.
There was one thing I just wanted to pick up on, and it relates as well to what Ian was saying. You talked about how the product is what it is, so the sizes are what they are, and of course it makes sense from a sort of economic point of view to use all that. And you showed how by adjusting the size, changing the size slightly, it has very minimal impact really on the aesthetics. But do you come up against conservation officers or architects who are just hell-bent on repeating that historical and who don't understand that?
Yes. Yeah, it certainly happens, and there are occasions where you can make the argument, and you can sort of express that it's a pure coincidence of what was available. Sometimes it works, sometimes it doesn't, and you have to make a choice in terms of, is the quarry capable of doing that? Will the client actually pay the bill for having a special? And it becomes a balance at that point. It is doable. It generally extends lead times, and it generally inflates the price.
Yeah.
So
I think it's a sort of question in the conservation decision-making process. What are you conserving?
Yes.
Are you just conserving the exact appearance of that building?
But
Or are you conserving the heritage and the tradition of using those random materials?
As we're trying to sort of touch on, is the colour and the overall appearance is far more overriding. I'm sure Ian and I, certainly looking at a slate from the ground, you can probably make a hazard a guess at what size it is, but it is hazarding a guess. without actually measuring what that gauge is, you don't really know.
Hi. Is
Hi.
just the two methods of splitting. Is there any difference afterwards? Is the decay of the slate different because of the compressed air or cutting it by hand, or
No, the durability is completely unaffected. You're still doing the same. The end result is still exactly the same. It's just the actual process of doing it. So rather than that being levered by a man prizing with a chisel, it's compressed air is just forcing that cleave open.
Thank you, John. Also, in other uses, do you include furniture and billiard tables?
Welsh Slate isn't used as billiard tables any longer. There are far cheaper alternatives that can be machined completely flat. But yeah, historically, it certainly would have been, as you say, furniture, countertops, and this type of thing certainly still are.
Okay, well, I'm glad to see that our final speaker, his taxi, has made it through the streets of London and the traffic. So I think you're getting mic'd up there, Richard? Possibly. Thank you, John.
Thank you.
So I'll start by introducing Richard while we're waiting for it to come up here. So he's a specialist in historic roofing. He's an old friend of Historic England. We've worked with him for a long time. And Richard was sort of probably, I don't know, climbing over roofs before he could sort of walk properly. So he learnt roofing from his father. So it's sort of really in his blood. And a number of years ago, he undertook a William Morris Craft Fellowship with the Society for the Protection of Ancient Buildings. As you will hear, come on up, Richard, an absolute passionate advocate for traditional roofing and for training. So
Thank you.
Very nice to see you here, Richard.
Okay, afternoon, everybody. So I'm going to be talking about St. Michael's and All Angels Church in Thorpe, Satchville. A parish church that is around 15th century. Repairs were carried out around about 1860 to 1880. But first, what I want to show you is the characteristics of this slate. So this is called a Swithland slate. It's from pretty much centre of the country. So unlike Welsh Slate and Burlington, shipping was difficult, transport was difficult, everything was difficult, and the material was difficult too. That was pretty much its area. So approximately about 8 miles and roughly a mile wide. So yeah, a small area. The other thing is that the slates were very long but very narrow. Okay, so when you put that into the context of the British standards and standards in general, they don't actually conform, but they are a beautiful looking slate. And it was down to the craftsman. That was how these slates worked. It was understanding the texture. They're very rough. If you can see possibly on there how textured they are. So you're using texture. You're also using a different maybe lapping system to get these to perform. So Thorpe Satchville, around 2010 we was asked to comment on the condition of this roof. So for safety we put a scaffold up. Always good when inspecting a roof. You need area to open the roof and have area to put the slates. And when we first got up there, before we started unpicking and opening, it didn't look too bad. But this is an issue with roofing. It looks okay, but its actual performance is what's underneath. Okay. So as you start to unpick it, you come across details like this where there is insufficient headlap. But this roof wasn't leaking. Okay, so you start looking at this and you start questioning why wasn't this leaking? So this is about the material. We're looking at how we're going to get this material. Very different, like I keep saying. And basically the slates and the ceiling were all one. So the slates were pressed into mortar, and the mortar was then pressed through the plaster laths. And the scratch coat came from the mortar that was pushed through. So you're encapsulating everything as one. So the roof was taken off, and it kind of tells a story. So if you can see the large lump in the sort of centre of the picture, that is where mortar has been pushed back up, and that's where the head of the slate was. Okay, if you look where underneath, there's the tile batten, so it's very smooth, and you've got the imprint of the wooden slate lath, and then the rest of it is where the nibs have broken off. Well, there was no nibs because everything went down and then scratch coat. We had the lime analysed, and I'll leave that there for you to have a ponder on. Just because it baffles me. This roof had to work with the right kind of mortar, and if you quickly read that, that was the reply back. Okay, so the top and bottom of it, it was an airline, possibly mixed hot, but unless you burnt the lime to get the right size, there's no point. So we might as well use an NHL, which actually would perform very different. So we took no notice of that, and we did some samples. And part of this program was that the architect, unfortunately, had to retire through ill health. Someone else took the project on and wasn't, well, I'm going to say it, they weren't conversed in this kind of slating. So we put a training day on. He asked me how to write the spec, at which point I laughed and said, well, I've done my bit, now you've got to do your bit. But if it was me, I would write what you would like as a finished roof and let the roofers explain how they were going to do it based on what we'd done through the training. Strangely, we then ended up doing the work. Not me, the lads that we work with, and he still asked us to do the 4 square meters, which I was very happy with, because even though I'd done the training, it wasn't me that was doing it. He needed to see for himself. So safeguarding, the rig was left there till the end of the project. The thing that also came out of this, that if you plaster lath on top of the rafters as if you would be doing a plastered ceiling, you got very little mortar pushing through. Okay, and you can see it there, and you can see the light coming through. So if you can kind of try and remember what it looks like, when you open it up, you get more light through. You also get more mortar going back the other way, and that gives you your scratch coat. Okay, so now we've got the system, we know what we're doing, and we were happy with it. 4 miles of lath later, okay, that bit was done. And you kind of try and put that into perspective, and I did the maths about 5 times because I couldn't get my head around 4 miles. So we battened it up, exactly as it was, and we carried it out. Plasterer followed behind, so working with the plasterers, and we had the inside finished. But this led to the problem of what do we do with the slates? How do we find a product that stopped producing in around 1887? Okay, a lot of so it was a vernacular material. It didn't travel that far until the railways came in. And when the railways came in, it went on the roof of the Renaissance Hotel at St Pancras, part of the gift to London from the Midlands. We'd worked with various materials for Swith, stuff that Burlington had supplied, random diminishing slates as we see now, the kind of tunnies that Welsh Slate supply, but we weren't getting that visual. So a conversation was had with Welsh Slate, and we took a box of this, which people say is waste. It's not. It's just a byproduct of the production of Welsh Slate. Is that a fair comment, John? Yeah. So we took a byproduct. We weren't trying to spit thin slates. We were trying to produce slates that were like a rugby crowd. You know, you've got big people, small people, short people, tall people, home kit, away kit, but all wanting to have fun and enjoy the moment. And we managed to produce these. These are from a little bit earlier, probably 4 years earlier when we looked at this. I'm not from Leicester, but Swith plays a huge part in my life. So we produced them for the rear of the church. So again, you got slates of all sorts of thickness. We're not as precious in our splitting. If we end up with a chunky one, we'll dress it. If we end up with a thin one, we'll dress it. The block will just give us whatever we have. And our technique when we started off was very much like John was showing with the slater's knife, splitting by hand, and slater's knife. We've kind of moved forward slightly, but still using a machine that's probably 250 years old. Probably a bit longer than that. And that was what the front looked like after. And 4 weeks ago, that's what the back has weathered like since 2015. So we've done a small scale for a colleague with some Trevillet to make some scantles. But most of this traditional method and technique we do with Welsh Slate. You know, it's a partnership that, is it a partnership? I don't know what it is, but it seems it works. Whatever it is, it works. And we're trying to bring the craft skills of the slate maker back, which my daughter's now kind of taking on. And we want to keep those skills, well, bring them back and drive them forward. But also the skills of everyone else that's involved, the woodsmen, the slate layers, or slaters and tilers. It's the whole thing about how we can go back if we want to. So a lot of work goes into it, but yeah, that's it. I'm done. Okay. Is that all right, Alison?
Thank you. That was unusually short for you.
Well, I'm trying to catch up.
Well, you can relax now. Thank you. Right, any questions for, Sarah?
Hello.
Hello.
When you say that the roof wasn't leaking
Oh, yeah.
water, how did you know it was failing? Was it plaster drop from the ceiling?
How did we know what, sorry?
The roof was failing. Was it plaster? Was there plaster drop internally?
No, we weren't. There was a little bit of plaster drop, but when we opened the roof up, we was looking at how the slates were lapped. So they should have, what you see, a margin, a bit that's cover, and then head lap, so 3/1, 4/2, etc. So when we were opening it up, we were finding that, let's say, 4/2 wasn't reaching to, so there was negative head lap. So water had to be going in, but it was the air line that was producing that sponge, if you like, that would soak up the excess and then release it. Whereas that's why we had the problem with the NHL. or I had a problem with the NHR.
Thank you.
Okay. Another question there.
What about the thermal insulation of the new roof? Does that vary at all from the old?
Well, we put it back as. That's the top and bottom of it. I struggle with all this personally. You know, I'm a bit old school, although I'm only 32. I'm old school, and I think if we start looking at how we introduce insulation, you know, and I'm probably talking out of turn here, we're going to affect how that building performs. All we're doing is moving a problem. We're not actually solving a problem. We need to be perhaps wearing wool fleeces. Aaron jumpers, apparently. So.
Was there any negotiation with the local authority, or did you just carry on?
Well, as it is.
With
The local authority?
The local authority were involved. Obviously, it was a grade 2 star. It was a place of worship. They were involved. I was kind of out of those conversations because I'm just a slater. So those conversations were had and dealt with prior to contract.
Okay.
Was the slate was just secured entirely by mortar? Was it no pegs, no nothing?
No, they were nail fixed on this one.
Oh, right.
Yeah, they were nail fixed. The mortar, but if you think about me and my arms are a nail and I'm hanging with my shape, I might last a second. But if I was to stick a Velcro patch on my tummy and one on the wall and did it, I might last 3 seconds. So the mortar is actually taking the pressure off of the nails, supporting it, stopping wind uplift, drafts. So all the things that we're looking at with the thermal performance, we're kind of trying to stop that by doing it in a traditional way. Roofing has changed a lot. We have membranes. You know, we're seeing a lot of failure in Swithland slates now that are coming off. That is maybe to do with deterioration of felts and membranes, where the moisture can't escape quick enough and freezes and then starts to powder the head of the slates. Whereas we didn't see any of that on this job.
What was the reusage of the originals? Is it do you have much waste or?
Yeah, we had a lot of waste. But so if we go back when it was last done, we think they attempted to do it right, shall we say? But because they'd stretched it, they'd not coursed it right. By the time we'd brought everything together, dressed it, sorted it, sized it, reholed it, we had just enough to do the front. There was a little bit left over, but not enough to put anywhere else.
More question. Oh, Ian at the front.
Oh, we'll have this.
You're on.
Wow, right.
Yeah.
So you mentioned that the slates were very narrow. So were you able to put the roof back irrespective of the fact the mortar was doing a job as well in terms of keeping the building dry? Was the slate head lap and side lap sufficient if the mortar hadn't been there, given the narrowness of the slate?
Well, originally, no, because it had no head lap. So the side lap it didn't matter, it was irrelevant.
No, but
going back,
reslated for me.
Yes, so reslating, yes. We couldn't improve side lap in the width of the slates, but what we could do is we could improve the side lap by understanding where water travels using the slate texture, by increasing head lap. And I don't want to give too much away, but let's say going back to more traditional techniques. The line, that obviously gave us comfort, knowing that it didn't have any head lap and didn't leak. If we gave it head lap, then we'd got the comfort of that mortar. And I think this is the problem, that with these kind of vernacular slates, if we was to look at this, I would say that you would have lost probably around 70% of slate in the lower courses that were actually good quality. So if you'd have gone by the standards, they would have gone. Basically, what we're talking about here is that your minimum side lap from the joint of the slate above to the joint of the slate below is calculated through head lap, exposure, and then a factor. And that's come more apparent through modern slating techniques. So when we look at these traditional ones, and Swith is only, or Swithland Slate is only one area, you know, you go over to Harnage and things, more of a stone, you still have similar problems. Some of the slating system techniques, whatever, in Cornwall is very similar to that. So it's the skill of the slater understanding and handling water. We're water handlers. It's top and bottom of it. We're trying to get it from A to B and stopping it going to C to Z.
Just
Thank
you.
you,
One more
Richard.
question there.
What is the ridge detail?
The ridge is clay, roll top. That is, I don't know if you can see it on this, but this job was completed in 2014. That picture was taken end of 14. This picture was taken about 4 weeks ago, so it's 9 years on. That was a hot mix mortar, so you know, quick lime aggregate, and it's performing. In the joints, it's gone, but the joints are very different traditionally. They aren't bedded, they are buttered, but you put shales in to stop water ingress, and it's all these little things that you I don't know whether you saw on one of the pictures early on, there was a bit of slate stuck in the mortar. You know, a lot of people say that was a scruffy roofer, but actually it was there to increase and give capacity on head and side lap on the shoulders. So there's all these little items that get unnoticed and missed that lead to problems. Then we try and deal with that problem in a modern way.
Are there also other ridge details that you come across, perhaps lead or?
Yeah, so there's lead, there's obviously clay, there is slate. Burlington and Welsh Slate do nice slate ridge. Molten Mowbray was a prime one with a Westmoreland slate with Westmoreland ridge on it. Very expensive, and can't imagine they'll come down in price. But you've also got where you use slates, where they interlink. And there's some different techniques of that in Devon and Cornwall, where you've got the slates come up, you've got a slit in one and a tab on the other, and the tab goes through, and you drop a nail and put a blob of mortar. And they are on roofs where you are high up looking out over the Atlantic. So it's the mortars, you know, to get these slates and to keep our landscape vernacular, we need to be looking at this.
And of course, for all these details and techniques that you're describing, there is no British standard, is there?
No.
So you need architects, you need roofers to work together.
Yeah.
To have the confidence in those old techniques.
Well,
because if everyone falls back on the British standard, these roofs will just be gone.
Yeah,
won't they?
disappear.
Yeah.
Completely disappear. And we need to look at, you know, we're small, you know, we make small numbers, but we also need to create the craftspeople.
I've got another question there.
I suppose that's, you mentioned it a few times, that scantle roofing, which is predominantly in Cornwall area.
Yeah.
Is that much similar to what you've done? Although I think, from memory, when I've observed the scantle roofing in Cornwall, they're smaller slates.
Yeah.
Probably Delabole slate. But I suppose, like all these slates, years ago, back hundreds of years ago, they used local materials.
Yeah.
And local craftsmen done things different from 100 miles away. You know.
Yeah, of course. Over the last, well, we'll start Cornwall, and you say Delabole, but it's not just restricted to Delabole.
I know, yeah.
But that's, everyone knows that one. The system that they worked out, scantle means scavenge, and scantle came out about the people that couldn't afford to have a nice rag roof or a whatever roof, and it was them going over the heaps, trying to make very small slates. That you've all got a smartphone, I would imagine, and if you haven't, please ask someone to show you. But a smartphone is the size of the Scantel slates. You know, they go down to 5 inches and generally up to 15, but you'll only probably get one course of those on. So they're very small and they have to be laid in a different system. And I think that system is due to not maths, shall we say.
I noticed when I visit Scotland quite often, I was only there 2 weeks ago in the Outer Hebrides, and they use the Ballachulish slates here.
Yeah.
And they're much smaller as well.
Yeah.
It's obviously for the winds and the bad weather they get, obviously.
Yeah, but
not obviously bigger headlaps, no doubt, you know.
Ballachulish used to produce some big. Scotland produced big slates. It's just like everything, isn't it? It's a economy of the quarries. Quarries work very differently now to what they did maybe 50 to 100 years ago, and they would have been operating then differently to what they would have been 200 years before that.
Yeah. Thank you.
So, oh yeah, please. So, I mean, you've touched on the skills, and obviously that is absolutely vital. But if somebody wanted to learn the skills that you've got and these traditional roofing techniques, how can they do that? What training is there?
Well, training. Okay. Oh, are you pushing me today?
Oh, sorry.
No,
I'm
I'm
just-
only teasing. So,
No, you love this question.
Yeah. So training is something that is close to our heart. We are looking at life site training projects where we want to work with communities. We want people to aspire. I worked with my father, my daughter, who stood at the back. She's third generation. She's the one that's more involved in the slate side, but also on the tools. Her brother didn't want to know at all. He just can't understand what we do. Saying that, we don't understand what he does, and we just laugh at him. But we're trying to look at how we can evolve and change training. Anyone who wants to come and have a go, all they've got to do is get in contact. They can come and have a go. That's not a problem. As for core training and taking it on further, there are qualifications. Those qualifications are based more around, or the qualification side is based more around 5534, the British standards for slating and tiling, which is modern build. What we're looking at is that through the training, we take them up here, give them all these other knowledges, working with marking sticks. We've done projects where we've banned tape measures and we've set roofs out that perform. And it's about having fun. You've got to be smiling and having fun. So we take them up there, we bring them down for the qualification, but they've got the knowledge to go on and do this. The courses with Historic England at West Dean that we run, the slating and stone and the clay tile, you know, I think they're good, but I'm not, I'm going to say that. But that is more about the things and the techniques, traditional techniques, how mortar can work.
And do you tend to find it's sort of people perhaps who have already been working in the roofing industry who think there's got to be more to it than just slapping on regular tally slates? Or do you get youngsters who are really interested in learning these skills?
Yeah, so at the moment we've got a placement through Historic England that's gone out there. We know of an 18-year-old who is at college that we did a little bit of roof training with them, and they're at the flower show at NEC next week. We put a roof on their design and got them to do that. He's shown interest. We don't get a lot of slaters that are accustomed to laying size slates because half the time they think they know it all. And you're never going to... sometimes you get them and they will listen, and the whole technique is very different. Penmine Cottage, one that we did over in Dolgethai, that roof was about 241 years old. We salvaged probably our biggest recovery ever of about 80% of the slates. So very vernacular, thick, local Welsh slates. About 17 and a half down to 6s. Of the 80% salvaged of the slates, we recovered about 60% with the wooden pegs in. And the wooden pegs were that good, we left them in and put them back on. So there was a cost saving, which is unheard of apparently. So I was told yesterday, no one gives refunds or, savings. So there was a saving on the material, but it was the technique in how it had been laid that allowed those pegs to be good to go on to do at least another 240 years, because it was lack of maintenance that had failed that roof. It had to be stripped because a lot of the frame had gone. So it's all sorts of techniques, but they're not learnt in college. That's why we're looking at working out in the field and doing more on site. And it's all part of the picture. We're going to lose our landscape, if the historic landscape as we see it.
Okay. So I can't see any more hands going up. So I think with that, I would just like if we could just show our appreciation for Ian and John and Richard, and also thank you to the tech guys who kept the show on the road, and thank you to you for coming. And I hope we'll see you in a couple of years' time at the next Stone Show. Thank you.